Okay, my name's Justin Wilson. I've been a network consultant now for going on 10 plus years. Been in the ISP industry since 1993. I'll kind of skip over a couple things in my presentation. Most of you have seen my presentations in the past, know I'm kind of fluid with them a little, so we're going to cover some topics today. MPLS kind of seems to be one of the themes of the conference, so I'm not going to do a deep dive into MPLS, how to configure it or whatever. I'm going to give you some things to think about. Why I should deploy MPLS or why I shouldn't. I'm big on network design philosophies. We talked about that earlier on our panel. Lessons learned on the old interwebs, Facebook, things like that I see that happen, over and over. Some things you need to look for in the next coming 18 months. Got some extra stuff, and I got a couple giveaways at the end. So, here's the obligatory who I am slide. Like I said, I'm the CEO of MTIN.net. We also run a peering exchange, Midwest IX. If you have any peering questions, you're looking at joining an exchange, whether it's us or anybody else, come talk to me. We'll gladly walk you through some of the things you have with exchange. I'll get to my contact information at the end of the slide, so don't worry about that too much. Okay, MPLS, VPLS, all this stuff. You guys probably recognize these guys from the commercials a couple years back. So we want to take a step back and look at why we want to run MPLS, or why are we considering it. Like I said, this isn't a how-to, so don't worry about real technical. So MPLS, what does it give you? It gives you scalability. You can do traffic engineering. This is different than what you can do with some IP protocols. You can do QoS. You can have redundancy. Kevin Myers had a very, very good presentation earlier, yesterday I think. MPLS is independent of being a layer 2 protocol or a layer 3 protocol. And so you ask, well, I'm already doing this with OSPF or BGP or even ISIS. So MPLS is not routing. A lot of people, I need to convert to my OSPF network to an MPLS network. MPLS is referred to as layer 2.5. You still, if you want to pass IP packets around your network and you have a total MPLS network, you still need to be running things like OSPF or BGP. You need to be running an IP protocol on top of the OSPF. Anybody in here running RIP? Good, because we're going to go have an intervention if you're running RIP. Anybody running static routes? Okay, are you considering MPLS, or are you happy? Yep, exactly. I mean, we've had clients come to us. I have this statically routed network, 10 towers or whatever. I want to go to MPLS. Well, why? I heard it at a conference. I read about it. Well, again, MPLS is one of those things. It has drawbacks, and it has the features we talked about earlier. If you're running static routes, or if you're happy with your routing protocol, if you want to go to MPLS, you're going to have more administrative overhead, at least initially. All your equipment's going to have to support larger MTUs. You're going to make your network much more complex. And I'm in this boat. Change is scary. We ran OSPF networks for years. We had 70 tower sites running all OSPF and some IBGP, and we were happy. So the question you need to ask yourself with MPLS is, do I really need it? Is there a business case for it? A lot of the technical guys, oh, I like MPLS, it's going to be awesome, it's going to save the world. Well, look at how much time, effort, money, whatever you're going to have to put into MPLS to make it work. Is that worth it to you? Some people have a business case, some people don't. So when you start diving into MPLS, one of the first questions that always comes up is it secure? We all know IP addresses are easy to spoof. Labels, which is something that MPLS uses, and like I said, this isn't technical, so you can Google all these terms, labels, PE routers, all this stuff. A label is almost impossible to spoof. So what happens with MPLS, if you're running an MPLS network, the IP routing is usually what gets attacked. Whether it be a man-in-the-middle attack, DNS, whatever it happens to be, or the customer router gets attacked. So you've heard the term VPLS. There's one very good reason for, hey, I'm going to MPLS, good. Now VPLS can really help me. We have a lot of LTE clients that are startups, so they don't have legacy IP space. They're having to buy IP space on the open market. So one of their biggest concerns is, how do I stretch my public IP space out as much as I can? They're going after business customers who almost always need a public IP address. So if you have a VPLS core, you can actually tunnel back to a central location and put all of your IP addresses assigned out of one single pool. That way you're not losing IPs by subnetting. The kind of extended way of doing it is you route out, say, a /29 to a tower. Is that good enough? Do you need more? It's kind of not really a crapshoot, but you have to do a lot of pre-planning and some guessing. If you're doing VPLS tunnels where you're assigning IPs out to your customers, you're pulling all from one big pool. Now, we could go into the discussion, triple PoE versus DHCP and all that. That's secondary to this. So before we go on, does anybody have any questions on why we should implement MPLS, or are you on the fence, or anybody have any thoughts? Okay. So one of the things I really like to talk about is network philosophy, network design, things like that. So there's all kinds of ways to design networks. Again, we'll bring up the triple PoE versus DHCP, OSPF versus IBGP. All this stuff comes into play when you're designing networks. So here's a slide I found a couple years ago that I really like, that explains some of the why I want to use MPLS. We have a couple offices we want to connect to. Maybe they're sharing servers, maybe they're sharing whatever the resource is. So if you're an ISP and you have a big client that has multiple offices on your network, maybe MPLS is the way to go. Maybe EOIP tunnels are the way to go. Both of those kind of accomplish the same thing in different ways, but it depends on what goals you're trying to do. So one of the first things you need to know is not really how to implement the technologies, but what they are, what their strengths are, and what their weaknesses are. This is going to help you in your design. So one of the things that kind of got floated around on the Facebook pages earlier this year was the idea of a switch-centric core design. So this is a picture of our fabric from several years ago, pre-MikroTik switching. The idea here being is all of your transport, your transit circuits, and things like that are terminated on switches. Switches switch, routers route. So if you have your transport circuits, your upstream providers coming into a switch, and then you have your core routers into that switch as well, you have quite a bit of flexibility. And you'll see a little diagram I put together later in the presentation, but it allows you quite a bit of flexibility when it comes to upgrades, when it comes to swapping out hardware, when it comes to upgrading hardware. If you can see down in the bottom here, the uptime on that Cisco switch was over 3 years. During that time, we upgraded routers, we upgraded OS on the routers, all kinds of things. So it allowed us to have a very robust core design. Now, if we wanted to get crazy with this, we could have had a second Cisco chassis there, or in modern day, we can have a couple CSR switches that are in a failover type of situation. But we chose the chassis because it's rock solid. I've had these chassis underwater still running. I mean, there's been water coming out of the fans and they're still passing traffic. So here's another for a small data center. Same concept. We got a couple MikroTik x86 routers. All of our circuits are terminated on this little Cisco 3550. The 3550 is not really, that redundant. If we were going to redo this today, we'd have a couple switches in there to our two routers up there. So in this type of scenario, our provider circuits are usually our point of failure, whether it be a transport circuit, whether it be an upstream. But by doing it this way, we're pushing out our point of failure to somebody else. Hey, it's your problem. I've done as much as I can. If I want it to be really redundant, I may have to order a different circuit from you or something like that. So here's our diagram we're kind of talking about. And this was actually a design we implemented a couple years ago for a statewide ISP. They had a data center in the northern part of the state, and then they had one in the middle part of the state. So we up in the top, we have a couple switch-centric core designs with a couple CCRs running in VRRP mode. We have our BGP peers hooked to redundant switches. That way we can lose a switch, we can lose a router, and we're still going. One of the other things we can do is we're running tunnels between our two sites. So if our top half, say our two transport circuits go away, we can still have management traffic and other types of traffic go over our tunnels and peered down below, and they can get into the network that way. So when you're thinking of your philosophy, think big picture, long term, but maybe think small picture, short term. Because when this ISP started, this was one of the first designs we had. We're like, this is where you want to be. Your business case says you might be there in a year, might be there in 3 years, but this is where you want to be. So they started out with just one data center, one transport circuit, and they just worked through this. So this goes back to, what does it cost to plan? Plan for 100 customers, plan for 1,000 customers, plan for 10,000. How many of you have sat around a coffee table or the garage and says, man, it's going to be so cool when we get to 500 customers. It's going to be so cool when we get to 1,000 customers. Put it down on paper. If you're sitting around, just dream up stuff, because you're going to get there. Have contingency plans for everything. Look at everything on the network. What happens if this fails? What happens if this cable fails to Cogent? What happens if this cable fails to my upstream ISP? Know your pain points, know your limitations, know where those limitations are, know where those breaks are. If this breaks, how well can I deal with it? You know, am I okay with it breaking for 10 hours, 12 hours? What's my cutoff point? So now, what should you know coming up? That's why a lot of us are here. What do we need to go home and do homework on? Wireless. You know, MikroTik's talked about LTE. You know, LTE as a client type device. There are several other wireless companies doing LTE point to multipoint. We're seeing shrinking cell sizes. So 5 years ago, we could stretch our APs out where we could put customers on at 6, 7, 8, 10 miles. We're seeing those cell sizes shrink because we're wanting to push more and more data to the customer. So we're having to shrink those sizes to get the better modulations. And that goes along with our interference mitigation. As we shrink those cell sizes, we're able to not hear as much on our wireless stuff, and we're able to push more throughput to the customer. And that's, you know, as Netflix and everybody else comes up with streaming services, that's what customers do. On our exchange, we're seeing probably anywhere from 50 to 80% of traffic goes to one of 5 websites: Netflix, YouTube, Facebook, Akamai, and Limelight Networks, which hosts a bunch of content. It's all pretty much streaming services. So Brian Horn talked a little bit before about IPv4 exhaustion. You need to plan for it. What happens when I run out of IPs? You know, do I do carrier grade NAT? IPv6, is it there for me? Am I going to have to go out and do open market purchases? You know, what was it, Brian? $4,000 /24, somewhere around there. So you got to build that into your business plan. I mean, IPv4 is here. It's using. You're going to have it in some limited fashion or another. If you guys can see my little asterisk about NAT here, if you listen to Giannis's presentation, what would Giannis do on NAT? So how many of you are WISP providers in the United States? Okay. How many of you are CLIA compliant? Okay. How many of you don't even know what CLIA is? Okay. Okay. So CLIA has been my mission for the past couple months to get more information on CLIA, to get correct information on CLIA. The FBI used to have a good website called askclia.fbi.gov. That website no longer exists. The reality of CLIA is if law enforcement comes in, they can serve you with a wiretap warrant or they can serve you with a CLIA warrant. If they serve you with a CLIA warrant, it's big time. You agree, Dennis? You need to be ready to accept a CLIA request for information. Your network needs to be ready for it. There are several ways to do it. Trusted third parties, the WISPA open standard is pretty dated at the moment, so I've been trying to talk with some of the folks at the FCC because the FBI's kind of handed that over to them. But if you're in the U.S. and you're not doing CLIA compliance, you need to do it before something happens. You're gambling. We all like to think, you know, some terrorist isn't going to be using our network, but you never know. You know, it could be something a whole lot less, but they've deemed it on the level with CLIA. So if you're not running CLIA, come talk to me. Tell me your concerns, that sort of thing. Because as I'm trying to talk to the FCC and some of these folks, I want to bring those concerns to them. Tomas talked about automating your networks. That's something that helps you grow your business. If you're not having to monitor your network, if something's automating doing that, you can go out and install customers. So here's a little fun thing. Lessons learned from Facebook. These are some recurring themes we see quite often on Facebook. Protect your network devices. Put them behind firewalls. Put them behind VPNs. Whatever you have to do to protect the device itself. Firmware has vulnerabilities that can be uncovered, all kinds of things. So I put an asterisk behind the keep up on software updates. I always like to stress, you don't have to be running the latest, greatest code. You have to be running the latest, greatest code for you. And that means somebody in your organization has to pay attention to change logs, what some of the forum folks are saying with a grain of salt on what they're experiencing with new firmware. Sometimes it's, hey, I need to do this today because it fixes a problem we've had. Sometimes it's like, hey, we're going to hold off on this because everything's happy so far. Ground, if you're a wireless ISP putting stuff on buildings or towers, ground it properly. I don't know how many posts we see on a regular basis of lightning took out half my tower. Lightning blew off my radio on top of the building downtown. And then, modular networks, kind of like back to our switch-centric design. If we're having modular pieces that we can pull in and out without disrupting the network instead of having one huge router doing everything, then we're in pretty good shape. So, last thing I kind of want to skim through is on our internet exchange, we've had an issue of getting management access to our switches. Our closest tech that we can call is, an hour away kind of deal. If I had to drive there or one of my partners had to drive there, we're looking at a minimum of 4 hours to get there. So what we did is we did 2011s on a management network. So in the center of our diagram, we have two 2011s connected with a CWDM fiber network. So we have a color on a MUX that is just dedicated for our management network. The reason we went with 2011s on this is because we're not pushing that much bandwidth across these. This isn't a service provider network. The only reason we need this traffic is so we can see, is the switch up? Can I get into the switch? Do I need to get console access? I just need to get in and SSH to a switch. Some resources, anybody out there who's not a member of some of the WISP talk groups, it's pretty active, lots of stuff going in and out there. Come to some of the conferences, the MUMs, the WISPAs. I have several clients running tower coverage. I'm not a paid spokesman. Knowing where your customers are, how to get them is huge, saves you time. I'm a member of the Brothers WISP. There's a great, I'm not affiliated with Packet Pushers. There's a great Packet Pushers podcast that's been going for years. Very, a lot of it is kind of high level networking, cutting edge stuff, but it's, still pretty cool. So here's my contact information. Feel free to reach out to me. I'll gladly answer questions, that sort of thing. Here's all our domains kind of thing. I know I kind of rushed through some of this, but it's nearing the end of the day and had to make up a little bit of time. So Anybody have any? I do have two giveaways after questions, but anybody have questions?
If knowing's half the battle, what's the other half?
Just knowing's half the battle.
Okay, any more questions?
Okay, I have two giveaways. Who has more than 50 MikroTiks deployed? Who has more than 100 deployed? Okay, I'll step it up. Who has more than 300 deployed? Okay, 500, 700, 1,000. We got two. These guys get the prizes then. We got two VR glasses, so. This guy over here, so. Thank you guys for listening to my ramblings, you know. Catch me wherever, and I'll be glad to sit down and chat.